Everyone, thank you for joining our 22nd Kubernetes user group meetup Singapore. And before that, I'll hand it on the mic to Iman to give a short description about Rakuten. Yeah.
Okay, so our first kickoff. Hi everyone, good evening, and thank you for taking the time to attend today's Tech Talk. So first, let me introduce myself. My name is Imran, and I am from Rakuten Asia. So before we proceed with today's Tech Talk with Kubernetes, I'll give a short introduction about Rakuten Asia. So Rakuten Asia is part of the global expansion of the Rakuten brand and serves as the regional HQ of Asia based in Singapore. So our office houses the various verticals, business verticals, as you can see here. So we have a total of 11 businesses. So here at Rakuten, we believe in contributing to society by creating value through innovation and entrepreneurship. Our innovations to shape the future include cutting-edge drone technology, green initiatives, as well as empowering our own employees. We also have partnerships with global brands such as the Golden State Warriors and Vissel Kobe, the football club based in Japan. As part of our culture, we value a sense of unity and the spirit of entrepreneurship and ambition. Here are some of the events we had recently organized. So we've had hackathons at the start of the year, as well as career fairs and tech talks held on a regular basis. We've also organized social events for our employees, ranging from festivities as well as a family day celebration. So before I end the presentation, I would like to invite you to connect with us on our social media platform. So we are on LinkedIn, Facebook, as well as Instagram to get updates on the latest events that are happening at our event space. So with that, I'll pass the time to our first speaker, who is Swapnill.
Actually, you can let me see what I can.
Yes. Oh, this set of content.
So let's just say changing the whole screen, whatever is there. All right. Yeah. So, hello everyone. My name is Swapnill. So currently, I'm working with SAP as a senior AI platform developer. And thanks for being here today. Today, I will be talking about how to design a machine learning platform for model serving and training, and also what is basically a need for a machine learning platform. So why the machine learning platform is required in the first place? Why can't I just use my Jupyter notebook for a production and deploy it on a production? So basically, machine learning platforms helps in scheduling the workflows, or and also in the automation of a workflows. So in the model training is not a like one step process, or it's not a one time process. Model needs to be trained periodically to capture the latest market trends and the user trends. So the platform can help to schedule the cron jobs or the training schedule, so that the platform will read the data from certain locations and train the models periodically without any human intervention. Next, scaling platforms. Many platforms comes with a built-in scaling feature. So in current uh, uh, in a current complex or advanced machine learning models, it requires a vast amount of data to train. For example, the chat GPT, basically it's trained on the whole internet data. So to cater such large amount of data, platform also needs to scale. So the machine learning platforms can easily integrate with the third party object storage, so that it can train on this such vast amount of data. And also, when I say high availability, it's related to the basically the model serving. So the models also will scale up and down based on the traffic coming to the model server. GPUs are particularly expensive, and most of the model training and model serving requires GPU. So machine learning platforms promotes the resource sharing, so it can effectively utilize the resources, and it will become a cost effective, and it will save the cost. Next, the version control. So platform can help to track the changes to the code, data, and the model. And this is particularly important in case something goes down south, or there is some problem in the latest version. Then and the developer can easily roll back to the previous version. And finally, the monitoring, alerting, and debugging. This just give you the health of your models or the training pipelines. And if something is wrong, then it will be useful to debug into the problems, and also continuously monitor your production model server health. So these are the some of the functional and non-functional requirements for any machine learning platform. Training and the model serving are the two basic ones, and then multi-tenancy and monetization are also equally important. So as model training, as I explained earlier, is a iterative process, but it's not a one-step process as well. So it has multiple sub-processes like data sourcing, data cleaning, and then feature engineering, and finally the model training and model evaluation. So all this, the platform should support all these things. Then serving is like wrapping up the model in some server-based scenarios and then deploying it to the production, so that the other services and users can call the inference endpoints to get the predictions or the decisions. Multi-tenancy is like when one software is being used by multiple tenants, but the data or the configuration is segregated uh, for every tenant, so that data is not shared among the tenants. And finally, the monetization. This is from where the money comes. So this is also one of the one of the important feature for ML platform. So moving on to the non-functional. So functional requirements or defines what a platform should do, and the non-functional defines how it should do it. So these are basically these non-functional requirements are basically true for any software or any platform. So this is not only limited to the machine learning platform. It's a scalability, availability, security, resiliency, observability, and deployability. We'll see all these things in the following slides. So when it comes to model training, again, when it for like modern AI models, it takes a huge amount of data. So it's always beneficial for any model training platform to have a seamless integration with the public cloud providers. For example, the native support to integrate with AWS S3 or Azure Block Storage is equally important. So the model server can read the data from this cloud storages. It will train the model. It will learn the weights and biases, and it will learn to find the patterns in the data. And then finally, once the model is ready, the same model will be stored back on the cloud again. So and cron workflows will help to automate these things. So as model training, it needs to be trained every after certain time. So cron workflows will help to schedule the training pipeline. And finally, the DAGs, which stands for directed acyclic graphs. It's actually to create the pipeline of the multiple steps in model training. Like as I said earlier, it's not just a single step. It includes data sourcing, data cleaning, then feature engineering, then model training, and finally evaluation. So all these things can be architected as a pipeline using the DAGs. So the Apache Airflow and the then Argo workflows are two excellent candidates to build a model training pipelines. Next is a model serving. So once the model is trained, it needs to be deployed on a product on a server so that user can call the inference, or it can be used in the other services. The single model serving is one of the basic feature, but along with that, the model mesh, inference graph, and explainer are another use cases for model serving. So what are these things? A model mesh is basically when a single host machine is used to deploy the multiple models. So it's not like one model, one server setup. The single machine is used to deploy multiple models. And how it works is basically based on the traffic to the model and how the CPU is utilizing, the model will be loaded and offloaded from the memory. So this is very a cost-effective solution because it again promotes the resource sharing. So inference graph, like in current world, the inference scenarios are getting complex day by day. If we take an example of a model which predicts the dog breed, so it can be divided into two sub-models. First model, which basically checks whether the given image is of dog or not, and then the another model which checks the dog breed. So in inference graph helps to architect or orchestrate such complex scenarios where the output of one model server is given as an input to the another model server. And finally, the explainer. Let's assume that the inference from the previous inference graph predicted the dog breed as Labrador. But how do we know that why the model made this decision? So explainer comes to rescue in such scenarios. Explainer gives an idea, or it gives an explanation about the inferences. So this is literally a very important debugging tool. So it also gives idea like why this particular decision was made by the model, or why this particular prediction was made by the model. So it also builds up the confidence for the users about the model. And again, the model serving platform needs to support the multiple model frameworks. Currently, there are lots of model frameworks available in the market. The TensorFlow, PyTorch, Scikit-learn, and XGBoost are some of the popular ones. So for multi-tenancy, the Kubernetes namespaces can be used to segregate the workloads from different users. So it's a logical isolation. It's not like hardcore multi-tenancy. Again, one model, one host can be used to achieve the host level machine isolation. But again, like it's not like again there will be certain parts of the system which will be shared by all the tenants. So scalability is how well the software is able to cater the growing demands of the users or the data or the network without any major performance degradation or need to overhaul the system. Any machine learning platform can be divided into two parts. One is a control plane where all the system components and all the open source services resides, and another the data plane where all the user data or user workloads are present. To achieve the scalability of a control plane, Kubernetes horizontal pod autoscalers can be configured to watch the CPU, memory, and resource per second matrices, and based on the traffic or this utilization of resources, the system pods can be scaled up or scaled down. And for the data plane, basically Kserve internally uses the Knative to scale the inference services. So basically, Knative also has a very useful feature called scale to zero. So let's say in case there is no traffic to the server, but in certain cases the pod will be still running on a machine, so that it will incur the charges. So scale to zero, basically it will just kill the pod for a while so that there are no resources, so there is no resource consumption. As the resource comes, it will again kick off the pod and it will start serving. So the scale to zero feature is just like you can assume like AWS Lambda. Again, the Knative supports a two type of autoscalers. One is Knative pod autoscaler, which comes in built with Knative, and another the horizontal pod autoscaler, which comes in built with the Kubernetes. And the horizontal pod autoscaler supports the CPU-based autoscaling, and the Knative pod autoscaler supports the concurrency or CPU or memory related metrics and autoscaling. Availability is the measure to which the system is available for user to use. Highly available and fault tolerance can be achieved by placing the system pods or server into multiple region and availability zone. The Kubernetes topology spread constraints can be used to control the placement of a pods in a different host or different zones. So basically, if you talk about the AWS regions, so each region comes up with 2 to 3 availability zones. If we set a max queue is used to basically spread the pod as even as possible. So what this means? So for example, like there are 5 pods need to be placed in 2 availability zones, or let's say 3 availability zones. Then it will be placed like 2 in one, 2 in second, and 1 in the next availability zone. So it's just basically the difference between highest and the lowest. For overall security of any application, it's necessary to secure both the network levels security, which is basically the east-west traffic, that traffic within the cluster, and the north-south traffic, that is traffic coming into the cluster. So Istio has for Istio sidecar automatically configures traffic use MTLS with permissive mode. So what permissive mode is? So basically permissive mode means the traffic can be traffic within the cluster can be MTLS or it can be plain text. But it can also, we can be more strict and disable this by setting the mode as strict. Then Istio authorization policies can use to check the request or the request, the bearer token or the request header, and based on that, we can like check the scopes in the request, and that particular request can go to the particular endpoint. Then for this, we need to set up the authorization policy. Kubernetes is a very like handy or very popular tool to create the like any Kubernetes based policies. So it's again uses the Kubernetes objects. So it we don't need to learn any new language, or it doesn't require any new language. Finally, the resiliency. So these are like very basic or common resiliency patterns for any software solutions. So, and both Linkerd and Istio has inbuilt support for all these resiliency policies, like request timeouts, retries, traffic routing, and circuit breaking. For to gain the insight about this system, or to check how the system is working, the observability is very essential. It also like gives the health about the system, and alert helps to find out the problems even before the user reports it. So Promptel is a solution to strip the logs. Basically, it collects the data or logs from all these services and sends it to the log storage. Next, Loki is a kind of a log storage and a tool to visualize the logs. Grafana basically helps in designing the dashboards which can be used to monitor the health and the overall gain the insights about the system. So distributed tracing is particularly important when in case of microservices, where one request flows to a different services, and to debug such request, a distributed request tracing is really important. Jaeger and OpenTelemetry are like some of the tools which are integrated or which comes with the Istio, which supports Istio, are really good in like for the distributed tracing. So next, the deployability. So basically, GitOps is the process where all the infrastructure code, all the infrastructure is maintained as a code in a Git repository. So whenever user wants to deploy something to, or developer wants to deploy something to the production, developer just needs to create a PR. Once the PR is approved, it means that those changes are good to go to production. So Argo CD is a tool for the Kubernetes cluster, which can sync the Kubernetes cluster with the Git repository. And whenever there are any changes in the Git repository, those changes will be reflected in or will be shipped to the Kubernetes cluster. So like in this competitive world, it's very important to ship changes to the production more frequently and with ease. Finally, putting all this together, this is like kind of a sample architecture for any ML platform. So where you can see the outer box is everything resides inside the Kubernetes cluster, and it is using Istio for authentication and authorization purpose. Again, the overall system is divided into two parts: upper one green, the control plane, and the bottom one is the data plane. A control plane is where all the API servers or all the open source components or Kubernetes operators are present. And in data plane, all the user workloads, the training and serving workloads are present. Again, like all the user workloads are segregated with the namespaces. And this Kubernetes cluster, it's synced with the Git repository using the Arco CD. So whenever there is any change here, those changes will be reflected into the cluster with just a PR merge. Okay, so thanks a lot, everyone. And please let me know if you have any questions. Any questions from anyone? Okay.
Any questions from Swapnill? Yeah, so Swapnill will be around here, so you can directly reach him out. So thank you very much for interesting topic. So next, I would like to invite Vishnu from Srijan.
All right, so hello and welcome to the second session for Kubernetes user group. Today I'm going to talk about how you can securely troubleshoot your Kubernetes using a tool called nsenter. A little bit about me. My name is Vishnu, and I've been working as a platform lead for Srijan, a Material Plus company. My core responsibility is to basically make some resilient platforms which can host a variety of workloads from web applications to telco workloads on cloud as well as your data centers. You can find me on LinkedIn at VH Dadhich. All right. A little bit about the company, Srijan. We are globally known as Material Plus. We are a collection of 12 companies with a key focus on customer-centric approach in our consulting, in our design, and in our delivery. You can read more about the interesting stuff that we do on materialplus.io. All right, I'll move. Let's start the fun. Okay, the first question is how many of you are already using Kubernetes in production or willing to use Kubernetes in production? A raise of hand. Awesome. So now if you are working with Kubernetes in production, you must be knowing the pain of handling the Kubernetes in production as a Kubernetes administrator. So the real question is it really that fun? I mean, if you are a Kubernetes administrator, you will realize that it is not really that fun. Why? Because you see a lot of crash, loop back off, out of memory kill, eviction threshold reach, image pull error, and whatnot. I mean, not ready, image pull back off, node conflicts, network timeouts, etc., etc. So I'm pretty sure you must have seen, if not one, or all of these errors in if you have worked with Kubernetes in production, right? So now, if you have issues, of course, next step is to basically troubleshoot it, right? So how are you going to troubleshoot? Is this the right way? Probably not. So when you have a lot of issues and when you do a lot of troubleshooting, I guess there is no right way, right? If something works for your issue at that moment, for that issue, that particular issue, it is the right way. If it doesn't, it is the wrong way, right? But today we are going to talk about a particular tool which can help you with that particular troubleshooting. And probably it's already there running in your Kubernetes clusters, which probably you might not know about. Now, all right, so before moving forward, these are some of the most common issues which I have seen in my experience. First of all, network issues. Of course, if you're using Kubernetes and it's a distributed system, everything is connected using networks, then pretty sure you must have faced a lot of network issues. Like, for example, your one pod is not able to communicate with other pod, your pods not able to communicate to other services, your pods are not able to reach out to your image repositories, etc., etc. And no, not forgetting about the Kube internal service discovery issues, right? Of course. Then next issue which we usually face is the file system issues, right? So let's say when you deploy a pod and we have to mount it to a volume, sometimes you mount it to some file permissions you have to give, right? And that user is, let's say, not allowed to write onto that volume, then what, your application will start failing. Or let's say if you are running a web application that requires the user in running in the container to only write to certain volume, but the permissions are incorrect. So you will face a lot of file system issues, right? And then the process related issues. You're running pods in production, but let's say some of your pods starts hogging all the resources like CPU and memory of your worker node, and suddenly your worker node goes down. So probably you must have faced resource consumption issues with Kubernetes as well. So these are like broadly some of the issues that we have faced. There are a lot of other issues as well, but yeah, broadly you can say these are some of the issues which we have seen a lot, right? So now, before moving forward, I'll give you just a picture of today's example that we'll be talking about again and again. It's just a very simple Kubernetes cluster with one master node and one worker node. Nginx pods, all the pods have been exposed using internal Kubernetes service. We're not doing anything fancy here. It is just a simple, straightforward example. So now, when you run kubectl exec-it and then go inside the Nginx pod, and from there you just run a curl command on the Nginx service. Sorry, you will basically be seeing welcome to Nginx. If everything is fine, everything is okay in an ideal scenario. Of course, if you go inside a pod and you curl an internal Kubernetes service, you should be able to resolve it. You will be getting the output, right? And that is possible basically because of the three major networking components of Kubernetes. First is your CNI. CNIs like Calico, Ontria, all of them are basically providing the pod-to-pod network connectivity. It is important to make your overlay network. So that's where your CNI comes in. And without CNI, probably you will not even see your ready status of your nodes, right? So when you deploy a cluster, if you do not deploy a CNI, none of the nodes will be in ready state. Secondly, your kubedns. So kubedns provides you the internal service discovery, which means if I'm able to curl the Nginx-service, Nginx-service has to resolve to some IP, right? So that is what is provided by Kubernetes kubedns. Without kubedns, you will have to curl all the IPs every time. That is, of course, very painful. And then we have a kubeproxy. Kubeproxy is one component which does the IP table magic, which means, let's say if you have a pod running on one worker node and that wants to reach out to another pod in another worker node, how does the network packets will know where to go? So when the network comes out of a node, it knows via IP tables running on that worker node, right? So if you do not have IP tables configured by kubeproxy, you will not be able to reach out to another pod running on another worker node. So that is where your kubeproxy come in. So all these components basically sets up all your Kubernetes cluster. Fine, this is the ideal scenario. But let's say you run curl Nginx-service and you get this beautiful message. What will happen now is now this is one of the network issues that we have been talking about, right? We see a lot of timeouts and everything. Now, the first thing that comes to my mind is now we have to troubleshoot. How do we troubleshoot? I'll quickly try to log in into the pod, right? I want to log in into the pod and try to run some curl commands, telnet commands, nslookup, something, right? So when I run kubectl exec -it bash, it returns bash not found because it does not have a bash. Okay, then I'll try the shell sh. Okay, shell is also not there. You don't have bash, you don't have shell, which means probably you're running a distroless image. Now, what is a distroless image? A distroless image is an image that does not have a shell. Now, it is one of the best practice that we should always follow. And in fact, your Kubernetes components like kubeproxy, kubecontroller, kubescheduler, all of them are running distroless images. It's like one of the best practice that even Kubernetes has moved to. Then basically, I will also suggest all of you to move to a distroless image. So basically now, I want to troubleshoot, but I do not have a shell. How do I go inside a pod? How do I go inside a container? Because I cannot troubleshoot from outside, right? So the next step that probably I'll do is I'll build another container. So I'll use the same Nginx image, but now I'll build it with bash. I'll probably add some apt install some commands inside the bash. I'll build it again. I'll tag it. I'll push it to the and repo, and then I'll use the kubectl. I'll use the kubectl set image deployment, and I'll redeploy that particular container. But now it's with shell. Okay, so now I have shell. So now I'm able to run the kubectl exec commands with bash. It shows success. So now I'm able to log in into my pods. Now I can troubleshoot it, right? Not right. So when we logged in, we are able to log in into our Nginx pods, but we have to have some tools, right, like curl to basically troubleshoot it, to be able to see if we are able to reach out to a certain service or not. Or we have to use ping commands to be able to reach out to test it if you're able to reach out or not. And nslookup, telnet, all these tools basically help us to troubleshoot our networking problems. And then if you don't have all of them, probably you will try to apt install, which will not work if you are running any gap environment. When you don't have internet, you will also get this error. Right, so now what to do? We are able to log into the pods, but we don't have enough tools. Now, at this point, you might want to do again Docker build and do again deploy a new image with some of these tools. But what if I tell you, you already have a tool inside of your worker nodes, which can help you with this kind of situation where you do not need to rebuild and redeploy any pod, and you can still log in into the pod and then still use any of these tools which resides in your worker node. Then enters the nsenter. So before we get started, have you ever heard of nsenter or have you ever used nsenter before? All right, awesome. So basically what it's nsenter. So nsenter is a powerful command line utility that allows you to enter the namespaces of other processes and executes the command that as if you are within that namespace. In layman terminologies, you can log in into any worker node, and then from that worker node, you can run certain commands using the binaries and tools present on that worker node, as if you are running that particular command inside any of the pod. Right? So you don't need to log in into the pod using kubectl. You can log in into the worker node, and using that utility nsenter, you can run that command inside the pod. Right? So, how is this possible? Like nsenter, is it some magic or what? Like, how is this possible? So, what are containers exactly before we go forward? So, basically, containers are nothing but containers are Linux. So, a Linux container is nothing but more than a process in Linux. When you run a container, it will run as a process in Linux, nothing else. It's not magic. So, it shares the same host kernel with the other containerized processes. So you see, when you run a process, basically when you run a pod, when you run 100 pods, all of them are containerized on the same host, and same host is being shared by all the containerized processes. So what is the difference between a normal process and a containerized process? So first of all, your containerized process is isolated from all the processes, and that isolation is provided by technology which is called kernel namespaces. So inside of a kernel, you already be having a kernel namespace, and this basically technology helps you to isolate each container process from the other container processes. And this virtualization helps us to be a bit more secure. This is how the containers run. And then since you are running a lot of container processes that are isolated from each other, which have no idea about what other processes are running, there could be a lot of resource issues. A lot of container processes can start taking a lot of memory, a lot of CPU. In that scenario, you need to have a control over these containerized processes, right? So how that control is provided using kernel C groups. So kernel C groups are the control groups which restrict your containerized processes from taking certain CPU, certain amount of memory, certain amount of IO file system, not more than that. So these two technologies are basically used inside of your kernel, which helps you to run a containerized process. So now, just to give you overflow, the whole flow, when you run any Docker command, like let's say Docker run, what happens is your Docker daemon, it talks to your container D, like, okay, we need to create a container. Now your container D will basically pull the image and it will go to run C and lib container. These are like OCI standards, and they will basically help you to create your kernel process, or basically the containerized process. So all in all, like when you run a pod, Kubernetes pod on a worker node, it is creating a container, and container is nothing but a Linux process, which means if I'm on a worker node, I should be able to see all the container processes, right? So this utility nsenter basically helps you to run a program, a command within the namespaces of other processes, right? And there are a lot of options that it has. You can enter a lot of namespace types. Like let's say if there is a process and you only want to enter the PID namespace, which means you will be only you only want to see what PIDs all processes does the other container, other processes running. Or let's say if you want to enter the network namespace of another process, which means staying on your worker, you can check the network, all the network settings inside of the other process without actually going inside it. So yeah, that's where your nsenter helps basically. Now, how does this nsenter help, right? So I'll also show you a demo, but using nsenter command, you will run something like sudo nsenter and the process ID. Process ID is basically nothing but the process ID of your pod or a container or your Linux process where you want to enter. And then from enter, after entering, when you provide it hyphen n tells you that, okay, I want to enter the network namespace of that process. So when I have entered the network namespace, I can run any command which acts like I'm running that command inside that process, right? So when you do that, after that, whatever you run in your shell, a command that you run in your CLI will basically run as if you are running that command inside of your process, right? So you can diagnose all the network related issues. And the best thing about this is after you run this nsenter command, after that you are still on your worker node, right? But in your worker node, you have all the utilities like curl, ping, lookup, which may not be there in your pods, but you still will be able to use those utilities, but run that command as if you're running inside that pod, right? So we'll see that in action. but next is inspecting your process isolation. If you can inspect your process and the resource utilizations from the host perspective, for that you'll have to use -m -p, and similarly you can investigate the file system problems by using -m, UI, and p. All of them have a reason why they are put there. So if you do not use u, you will not be going into the user namespace, right? You will still be in the user namespace of your worker node. So if you do not use m, you will not be going inside the file system namespace. So all of them have been there are reason, like every option has its own meaning. So if you want to only enter network namespace, you can only press -n. Otherwise, if you want to enter all the namespaces of a process, you can use -a. Okay. Now, okay, now I'll show you a demo. I'm not sure how to do it. Okay, wait. So as I've told you, I have used Minikube in my local, and you can. This is the same process, same idea. It can work on your EKS, GKE, any other cluster as well. So yeah, I'll run the commands. So you can see when you run kubectl get nodes, you see that I have two nodes, multi-node and multi-node M2. One is your master node, one is your worker node, and then I have like 5 Nginx pods running, and then one service exposed, one cluster IP exposing all the pods, and that's it. That's a very simple setup. So now what I'll do is I'll log in into my worker node. So if you're using Minikube, you have to use Minikube SSH to log in into your worker node. So now I'm logged into my worker node. So now I'll have to root user, because when you want to enter the namespace of other processes, you have to be rooted, right? So now after I run the sudo I, now I can run the CRICTL command. So CRICTL is nothing but your container management CLI. Like you can use if you have containerd, probably you will be having CRICTL already. If not, then CTR will always be there. The same process goes for Docker as well. You can use Docker PS to see all the containers running. But since I have a CRICTL here, I'll use that. So these are all the processes running, and you can see like 3 of my 5-6 pods are running on this worker node. That's why I see 3 containers here, because on this particular worker node, I have 3 containers running. And I also have kubeproxy here and the Calico node. These are also running. So now I have told you earlier that all the processes, all the containers are nothing but Linux processes, right? So you see, right, I have ran the command ps aux, and you see these Nginx processes, like 3 of them, right? One is master process here, one master process is here, one master process is here. So these are not your actual Linux processes. These are your containerized processes, but you'll still be able to see them when you run ps aux command. All right. So now what I need to do is I need to get the PID of that particular process, which process I want to enter using the nsenter, right? So I'll run all these 3 commands at once, and it gives us the process ID 37280, which is basically the process ID of my Nginx container that is running there. And I have used CRICTL PS and CRICTL inspect to check the process ID of that particular Nginx container. And I'll do the same for kubeproxy. See that the process ID for kubeproxy container is equal to 0 and 280 is for Nginx. Sorry. Okay, and if I again show you the ps aux command, you see using the ps command also we see that's fine, almost done. And then when you run ps aux command, you will see that 37280 is indeed your Linux process, right? Now I'll run the IPA command. So IPA command is basically used to see all your network interfaces that are attached to that worker node, right? So when I see IPA, I see all these interfaces that are there. Okay, but what if I run the IPA command along with the nsenter and then giving it the process ID of the Nginx container? You see, now we see only 3 interfaces, which means from my worker node, I have just entered the container namespace and then I have ran the IPA command, but I'm still on my worker node, right? I'm still on my worker node, but I have ran the IPA command as if I'm inside that particular pod. But interesting thing is, interesting thing is if I use kubectl exec and then I log in into same Nginx pod and then I run IPA, there is no IP binary. There's no IP binary. Still, I'm able to run the IPA command from my worker node for that particular container. So which means if I do have some binary, some utility present in my worker node, right, but not in my pod, still I'll be able to run those commands using nsenter. How cool. So I have a few more examples and a few more use cases that I'll show you. I'll close this one. Okay, I've copied it wrong. Okay, so when I run the IP route command from my local, you see there are multiple routes. But when I run the same command using nsenter for that particular container, I'll see only 2 routes, right? So how is this helpful? How is this helpful in debugging, right? So let's say if I want to curl the local host of the worker node. I'm currently on worker node. If I curl the local host, I don't see any output, right? Because there's no web server running on my worker node. So there will be no output. But if I run the same curl local host inside my Nginx container, welcome to Nginx. So which means I've used the utility curl present in my worker node to curl the Nginx web server running inside the container, right? And again, to show you on the side, I do not have any curl utility present in my pod. So if I run curl command not found, but still I'm able to curl, right? So next thing is if you want to check the internal service discovery, like if the internal service discovery is working or not. Of course, when you use this nslookup utility on your worker node, you will not be able to resolve anything, right? When you use nslookup, it will probably fail, but you will not be able to resolve it. Why? Because this nginx.default.svc.cluster.local is the internal FQDN of your Kubernetes, which will not be reachable if you're not able to connect to your kubedns, right? So of course it times out. But if I use nsenter, right? If I use nsenter, I'll target the nginx PID, and then I'll do the nslookup on the nginx default service, also telling the nslookup to use the kubedns IP, right? So I'll run this command. Right now, I'm able to resolve my nginx.default.svc from my worker node, but it is possible only because I have entered the network namespace of my nginx, right? So if you see here, nginx.default resolves to 10.105, which is nothing but your kubectl get svc, right? 10.105.1633.4 here also, right? So I'm able to resolve any particular internal service discovery using nsenter from the worker node, right? And again, you don't have nslookup inside of your pod. You can check here, right? There is no nslookup. I have entered the pod, but I'm set to resolve and test my do the troubleshooting, right? Now I'll enter the file system namespace now. Okay, so as you see, when I ran this command, I have given -m and -u, which means I'll enter the file system namespace of nginx pod, which means now whatever command I'll run now, I will be running as if I'm running inside of your nginx pod's file system, which means I should be able to see the index.html, right? See, so index.html is not there on my worker node, but now I'm able to see it because I have entered the file system namespace of that particular pod. So using nsenter -m -u, you can enter the file system namespaces, right? So this will be helpful to troubleshoot your file permission issues, right? So as I've told you before, initially, like there could be a lot of permission issues, like which user is able to access which directory and if a particular directory is mounted or not. So in all those cases, you can enter the file system namespace of that particular container and then able to run other commands like ls-al, whatever. Okay. And then the last one is basically your process namespace. I'll exit the namespace. You have to exit the namespace once you are done troubleshooting, right? Because now I want to enter the process namespace as well. So now I've entered the process namespace as well. So now if you run ns-l on /proc, you should be able to see all your processes running inside that nginx container, right? Okay. Okay, so here you see I mostly see only nginx containers. There are some other processes like bash, ls, etc. But you do not see all the other Linux processes, right? Like containerd and all. There will be a lot of processes, which means I've entered the process namespace of my nginx container, and I only see these nginx processes. So this will be helpful. This will be helpful when you want to know like what all processes are running inside of your containers, right? Now I'll exit this and then I'll run the same command just to show you that my worker node has a lot more processes, right? You see a lot of other processes which are there on my worker node, but I only see nginx ones when I use nsenter and I go inside the process namespace of nginx. Okay, so these were all the examples that I had to show, like how can you enter the various namespaces of your pods, using which you can basically use the tools present in your worker node and then run those commands as if you are running inside of your pod without your pods actually having those tools. So I'll share. Okay. So what benefits am I getting here? I'm able to network troubleshoot even in the distroless images, right? So distroless images are basically your, the best practices images. So as I told you, like my Nginx image didn't had curl or anything, but I was still able to troubleshoot. So you can use the nsenter tool for troubleshooting even with the distroless images, and we don't need to bundle unnecessary utils, right? Like big curl and lookup, etc. in your production images, because lesser the size of your production images, better it is, right? That is the golden rule of creating a Docker image. You can see it on Docker's website also. If you go and see the best practices for creating a Docker image, you'll see the lesser the size, better the production image. And you probably do not want to have all these tools for a hacker to go in and then okay. So, and it works with air-gap environment as well, because most of the Linux distributions, modern distributions, are now shipping with nsenter. Probably if you are using your EKS, even your GKE, I have tested with EKS and my local Minikube, and most of the Linux distributions probably be already having this tool nsenter. Right, so you don't need any other tool. You don't need to install anything. You don't need to run anything. So it works directly on your air-gapped environment as well, right? You just need to have these tools in your worker nodes, of course. And then caveats. You need to have the SSH access to the worker node. So, if you are a developer who do not have access to worker nodes, then not possible. But if you are a Kubernetes administrator who has access to the worker nodes, then you can use it. And of course, sudo access is required because you are going into the namespaces of other processes, right? So it can only be possible when you are a root user. And then, of course, fiddling with the kernel namespaces is quite risky. So be cautious. But if you know what you're doing, it is an absolutely amazing tool which can help you troubleshoot a lot of things, right? With that, I'm mostly done with my presentation. Do you guys have any questions? All right, no more. Okay, yeah, sure.
Let's say if your pod assumes user service account to assume an IAM role, right? Can you run AWS commands to check whether or not it actually has the permissions assigned to IAM role? Yeah.
So this nsenter utility can only enter your pod using the nsenter command line. So if you want to check the IAM permissions that have been assigned to a role or a user inside a pod, right? Of course you cannot, because your nsenter is only used to enter your pod with the tools you already have on your worker node. If your worker node has access to do that, then you can do it with your pod as well. So it totally depends on what access your worker node has, and probably you would want to run this command to check the access from the worker node itself. You don't want to go inside the pod and check it. Or if you want to check it, if you have if you already have, I'm probably not sure if there's IAM authenticator, some tool which you already have on your worker node, you can use that using nsenter, of course, and you will be able to run any command which is already there in your worker node inside of your pod as well. Yes, you can do that. But if you go and enter into the network namespace of that pod, then you should have the reachability towards the AWS from your pod, right? So yeah. Anything else? Yeah.
Yeah, thanks. It's a beautiful session. I think it's very useful information. So I'm just thinking nsenter has a lot of power. Is there any drawbacks with that power? Like, for example, if somehow the worker node is compromised, so is it going to be used against? Like, is there any way we can restrict what nsenter can do through any configuration kind of thing?
Yes, as I told you in the caveats, I mean, it is a very powerful tool. You are fiddling with the kernel namespaces. You are jumping from one process namespace to other process namespace, which requires the root access. So, of course, anyone who has root access to your worker node can do a lot of things, not just nsenter, right? They can probably shut down that worker node. They can delete a lot of stuff. They can jump to other worker nodes as well. So, for sure, you should have all the authentication and authorizations which you usually have on all your Kubernetes systems. It is very dangerous or very harmful in case if some malicious user gets access to your root user. So same, I mean, you should not give any root access to anyone, right? So if they have access to an nsenter, they can jump in any process, kill any process, anything, right? So yeah, it is very dangerous. So, yeah, we have to be secure. Anyone else from there? Yeah.
Just wondering, does this nsenter utility comes bundled with all the standard Linux distro at the moment?
Yes, I'm running Ubuntu, so it comes with Ubuntu. I have tested with the AWS EKS standard images. It is already there. One of my customer environment who is running Photon OS, VMware Photon OS, they are also having this nsenter utility. So probably most of the modern distributions already comes with nsenter because it is a very basic thing inside of your kernel, right? So probably a lot of other processes are already using nsenter. So yeah, it is a very powerful tool. It is most probably it is already there. I cannot check GK right now, but if you have any GK cluster right now, you can check right now and let us know. Yeah. Anyone else? All right. If not, I'll be here around. Let me know. Thank you.
Thank you, Vishnu, for your comprehensive demonstration about nsenter. So we are not going to take much time. So I'm going to thank our sponsors, and then we'll have our quizzes game. So we are planning to give some swags, and first prize will be given away Code Cloud subscription.